All right, so starting percent yield. You have your basic formula for percent yield. It's the percent yield equals the actual yield. That's the one that you find in the lab that is actually measured on a balance or something. You're going to usually, given in the problem, they'll usually tell you this much is produced. When it says this much is produced, they're talking about in the lab. That's where they got it from. Anything where it says this much of the substance is produced, that's going to be your actual yield. On the bottom is the theoretical yield. Now you calculate that by doing a stoichiometry problem. So you're going to set up a t-chart always to figure out your theoretical yield. And you should always get that one from the calculation. And what the theoretical yield is, if every condition was totally perfect, that's the maximum amount you should get. Now most of the time, you'll notice in chemical reactions, they don't yield a whole lot. Some of them don't even get close at all to 100%. You know, like for some reactions, a 40% yield is actually considered pretty good. So, keep that in mind. Okay, so what we need to do here first, though, it says write, predict products, and balance the equation for the reaction of. So the first thing we need to do is figure out our reaction. Iron 3 phosphate. So once again, if I'm writing formulas, I go ahead and figure out what I've got for my charges. Iron 3 is Fe with a 3 plus. Phosphate is what?
PO4.
What's the charge on phosphate?
-3.
-3. So here, that's a 1-to-1. So our first reactant is just FePO4. Now let's look at our next reactant. We have sodium. What's sodium's charge? It is +1. Good. Sulfate. Anybody remember sulfate? SO4 -2. So for this one, we would need what? 2 sodiums, 1 sulfate. Now we have our reactants. So guess what we can do? We can predict our products. The iron is going to combine with which one? The iron should combine with the sulfate over here, right? And if iron is a +3 and sulfate is a -2, how is that going to look? Fe2SO4 with a 3. Good. Now our other one, the sodium should recombine with our phosphate here, right? And that means, what's that going to look like? How many sodiums do you need to balance out that phosphate? So it should be Na3PO4. Now we have to balance. So we got to make sure we have it balanced. What's out of balance right now? Sodium, we got a 2 and a 3. That one's pretty obvious. So let's fix those. Yes, we got to do the least common multiple and get them to 6. So we put a 3 here and a 2 here. What else do we need to fix? Iron and the phosphate. So if we put a 2 here, that should fix everything up, right? Okay, so now we have the balanced reaction we can begin. If I perform this reaction with 25 grams of iron 3 phosphate and an excess of sodium sulfate, how many grams of iron 3 sulfate should I make, or can I make? So this is a stoichiometry problem. This is finding the theoretical yield of the iron 3 sulfate. So basically all you do is start with your 25 grams of your iron 3 phosphate. We're going to go ahead and change that into moles and work it all the way to iron 3 sulfate. Oh, nope, that's not what I want there. Sorry. I'm going to 1 mole of FePO4. Already thinking ahead of my product. Now what's the molar mass of iron 3 phosphate?
150.82 grams.
150.82. Anybody verify that? Yes, good. That's what we got. Sounds good to me. Now we do mole ratio. So we have how many moles of iron 3 phosphate going to how many moles of Fe2SO43. This is going to be a 2, right? We put a 2 here. And what do we have over here? This is a 1, right? Last but not least, we need to change this to grams. So 1 mole Fe2SO43 is going to give me how many grams Fe2SO43? Anybody get the molar mass of that? Times 2, let's go here, 3 sulfurs, and we have 12 oxygen, right? Anybody get 399.88?
Yeah.
All right, sounds good to me. 399.88 grams. Now we calculate this, and this is going to give us our theoretical yield. So 25 times 399.88 divided by 150, and then divided by 2. And how many grams do we get for our theoretical? This results in, looking at here, we have how many sig figs? 2, so let's make it 33 grams Fe2SO43. This is the theoretical, because we did the Stoich problem to figure it out. Theoretical yield. Now, if 18.5 grams of iron 3 sulfate are actually made when I do the reaction, what is my percent yield? So, percent yield equals the actual over the theoretical times 100. So here I have 18.5 over 33 times 100. So what percentage do I get? 56, because we want 2 sig figs, sounds good to me. So we get 56%. Now, C is a good question. Is the answer from problem 1B reasonable? Is this a reasonable answer?
Yeah.
Yes, why? Yes, it's reasonable, but why? Because it's less than what? This is a reasonable percent yield because it's less than 100%. Right? What if you got an answer that was over 100%?
Impossible.
Why would that be impossible? What are you doing if you're getting a yield over 100%? You would be creating matter, and you'd be what? Violating the law of conservation of matter. So yes, this follows the law of conservation of matter. If you got over 100%, there must be other substance in there, obviously, too, that contaminated your lab, because you shouldn't get more than 100%. So if you ever get more than 100% and they ask you about it, is it being reasonable in terms of the answer, you would say no. Now for the last problem here. This is a fun one because they're giving us the percent yield. They're also giving us the other reactant, and they want us to find the actual. So this is kind of a working backwards type problem, okay? So, if I do this reaction with 15 grams of sodium sulfate and I get 65% yield, how many grams of sodium phosphate will I make? So let's start with our Stoich problem and find the theoretical yield. This case we're using the sodium sulfate, so that's the Na2SO4, and we're working it to which product? What did it tell us it wants to know about? Sodium phosphate. So we need to change the grams to moles here. Let's do that. Anybody with the molar mass? Sodium 22.99 times 2 plus 32.06 for the sulfur and 64 for the oxygens. How about 142.04? Yes? All right, good. Now we do mole ratio. So moles sodium sulfate going to the moles of the sodium phosphate. And I can't see the balance reaction, so you tell me how many moles of Na3PO4 were up there. Was it 2? How many moles of the Na2SO4? 3. So we're inserting our mole ratio. And now we're going to keep going to grams, so we get our theoretical yield. But we need 1 mole Na3PO4. How many grams is that going to be? 3 sodiums, 22.99 plus 1 phosphorus at 30.97, and 4 oxygens at 16. I'm getting 163.94. In that agreement? Are we in agreement? All right, so find the theoretical. Go ahead and calculate it. What do we get here? Don't forget sig figs at the end when you do your rounding. How much do we get here? What's our answer? Yes, we get 12 grams of Na3PO4. Now, according to our percent yield equation, we have 65%, right? We don't know the actual, that's what's missing. We know the theoretical is 12. So can we figure out how much was made? All right, so, divide by the 100 and then multiply by 12 to get your actual here. And what is the actual? The actual yield was 7.8 grams of Na3PO4. Very good. So this is the way that they will present the problems to you. They could have you work backwards. They could have you work forwards. Okay, keep in mind you're using the percent yield equation. Okay. You'll be finishing the back. Remember to be careful about writing your formulas. Balancing your equations, make sure they're balanced correctly.